Good day, viewers. This is 300 Plus Academy, still on the beautiful subject chemistry, and still on the theme electrochemical series. We'll be looking at UTME questions that directly relate to how we can identify reducing agents and how we can identify oxidizing agents, because oftentimes we do have questions that relate directly to identifying oxidizing and reducing agents from equation. Let's get right into it. The first question is 2015 question 48, as you can see on your screen, where it says in the reaction above, manganese 4 oxide, this is manganese 4 oxide, acts as what? We have option A catalyst, option B, an oxidizing agent, option C, a bleaching agent, option D, a reducing agent. Now, in answering a question like this, the best way to deal with this is to try and recall your definitions for oxidation and reduction reaction. Don't forget, we've looked at reduction oxidation reaction in terms of oxygen, in terms of hydrogen, and in terms of electron. Let's quickly look at this. If I look at this in terms of oxygen, I'm going to be seeing manganese 4 oxide as having lost oxygen. This is manganese 4 oxide, oxygen attached to the manganese, and here I have manganese 2 chloride, oxygen not attached. In this case, I have lost oxygen from manganese. I can say loss of oxygen from a substance is reduction. If I'm looking at things based in terms of oxygen, loss of oxygen from a substance here is reduction, and what we undergo reduction is actually oxidizing agent. So in that case, I am seeing my manganese 4 oxide as oxidizing agent, and that's just ends that. If I look at things for example in terms of hydrogen, a loss or removal of hydrogen from a substance is actually oxidation. HCl, now this is a chlorine gas. Loss of hydrogen from a substance is actually oxidation. That's removal of hydrogen from a substance is oxidation. So if I look at this, what will undergo oxidation is actually my reducing agent. So looking at this question, I can say my manganese 4 oxide is acting as an oxidizing agent. Option B is the correct answer there. Still on the same 2015, this time around question 19, you can see the previous question was 2015 question 48. Now we have 2015 question 19. So which means if we are able to identify our reducing and oxidizing agent, at least that could get us 2 questions correctly. That's about 5 marks thereabout. Okay, 2015 question 19, as you can see on your screen, it says in the reaction above, the oxidizing agent is what? So in this case, we were told to identify the oxidizing agent when hydrogen sulfide reacts with bromine to give us hydrogen bromide and sulfur. I can look at this in terms of hydrogen. When I look at from hydrogen sulfide to sulfur, this is looking like loss of hydrogen. Removal of hydrogen from a substance is actually oxidation, and what will undergo oxidation is actually our reducing agent. Recall that when dealing with UTME or JAM, it is about pace and precision. Since I've been able to identify that this here is my reducing agent, I just can say, okay, this is my oxidizing agent. But for the sake of completion, let's just go through it. For bromine to become hydrogen bromide, it means hydrogen has been added. Addition of hydrogen to a substance is actually reduction. So what will undergo reduction is actually oxidizing agent. I could look at this in terms of what we call oxidation number concept as well. Here, in the uncombined state, when an element has not combined or in the free state, oxidation number here is actually 0. When you look at HBr, if I deal with HBr and I want to get the oxidation state of bromine in HBr, hydrogen is +1, bromine is, let my bromine be X equals to 0. So in this case, X will be -1. So when I look at it, bromine moving from 0 to a -1 here, a -1, a decrease in oxidation number is actually reduction. Decrease in oxidation number is actually reduction. So that way I can still say from bromine to HBr, that is reduction. What will undergo reduction is my oxidizing agent. So in this question, I was told to identify my oxidizing agent. So the correct answer there is bromine. The correct answer there is bromine gas, and that is option C. So that is option C. That is pretty direct. It just depends on, in terms of what are you looking at your oxidation and reduction process. Remember that the two processes are opposite but yet complementary. So reducing agent will undergo oxidation, oxidizing agent will undergo reduction. We've had that in previous lecture videos, of which the link is going to be in the description of this video. Moving on to the next question, 2013 question 23. It says, in the reaction above, that's the reaction between zinc and copper sulfate, to give us zinc sulfate and brown deposit of copper, we were told to identify the oxidizing agent. In situation like this, what we're going to be using, this is here we were trying to use the definitions for oxidation reduction reaction. Here the best approach is to first of all write the ionic form of this equation. Now looking at this, in the uncombined state, zinc is actually having oxidation number of 0, plus copper with sulfate here, knowing fully well that sulfate is actually SO4 2 minus. So in this regard, copper here is going to be 2 plus SO4 2 minus to give us zinc 2 plus SO4 2 minus plus copper in the uncombined state, that is 0. Just like we've said in previous lecture, as per how we balance redox reactions, sulfate, whatever is the same on the reactant side and on the product side, strikes out, so that what we have is actually zinc plus copper 2 ion to give us zinc 2 ion plus copper. So when you look at this is going to be in terms of oxidation number concept. Increase in oxidation number is oxidation. So what we have here is, this is oxidation. Increase in oxidation number from 0 to +2. This is oxidation. And this here is going to be my reducing agent. So which means the zinc here is the reducing agent. When I look at my copper from 2 plus to 0 here, that is a decrease in oxidation number. A decrease in oxidation number is actually reduction. So this is reduction. A decrease in oxidation number is reduction. What will undergo reduction is my oxidizing agent. So in this regard, my oxidizing agent looks like the copper 2 ion, but the copper 2 ion is actually from copper sulfate. So my oxidizing agent here is copper sulfate. Looking very well at the options you have for that question, you see option B, seated comfy, copper sulfate is the answer, simply because copper 2 ion has been reduced to deposit of copper. What will undergo reduction is actually the oxidizing agent. So oxidizing agent here is copper sulfate. Still on the same 2013. So we've had 2013 question 23, still on the same 2013 question 22. So redox, identifying, reducing, and oxidizing agents is something we cannot overemphasize. You definitely will have that in your UTME exam. 2013 question 22. It says we should identify the oxidizing agent in this reaction, water reacting with fluorine gas. Of course, fluorine is the most electronegative element, more of the strongest oxidizing agents. So when you look at this, you'll be looking at redox reaction here in terms of hydrogen. This is fluorine. Hydrogen is now attached to fluorine. Addition of hydrogen to a substance is actually reduction. That is reduction. So what will undergo reduction? Oxidizing agent is what will undergo reduction. So when I look at hydrogen, water to oxygen, loss of hydrogen from a substance is actually oxidation. So what will undergo oxidation is actually reducing agent here. So in this reaction, I was told to identify the oxidizing agent, and this is pretty direct. Oxidizing agent here is fluorine gas. If you look at the option there, the correct option here is option D. Fluorine is the oxidizing agent, and that's just ends that. Straight to the next question, 2012 question 24. We have a reaction between sodium peroxide and water to give us sodium hydroxide and oxygen gas. We were told here to identify the substance that is being oxidized. We were not told to look for oxidizing agents or reducing agents here. We were told to look for the substance oxidized. Now, the substance oxidized here, that will mean that's going to be our reducing agent. Reducing agents are meant to be oxidized, while oxidizing agents are meant to be reduced. So in the question, as you can see on your screen, that's 2012 question 24, we were told to look for the substance that is oxidized. In other words, that is, you're told to look for your reducing agent. So when I look at this, this is free oxygen here. One of the ways is we can always look at the free elements to quickly, decode things with precision. You have water here, you have oxygen here. The fact that hydrogen has been removed from this water, removal of hydrogen from a substance, or you say loss of hydrogen from a substance, that is oxidation, sorry. That is oxidation. When you remove hydrogen from a substance, that's loss of hydrogen from a substance, that is oxidation. And what will undergo oxidation, that is actually your reducing agent. So in this question, asking us to look for the substance that is oxidized, that's the substance that has undergone oxidation, that is going to be water. The correct answer here is water. If you look at your sodium peroxide, you have sodium, you have oxygen. If you look at here, 2 times 2, that's 4 sodium, 2 times 2, that is 4 oxygen. If you then look at the fact that 2 times 2, 4 hydrogen has been added, addition of hydrogen to a substance, that is going to be what? Reduction. So what we were told to look for here is the substance that had undergone oxidation, or you simply say substance that is being oxidized. So the correct answer here is water. If you look at the option, that the correct option there is option C. Next question is UTME 2010 question 22. As you can see in that equation there, silver nitrate reacting with phosphine plus water. We were told to identify the reducing agent. Of course, the equation, we have 3 reactants and we have about 3 products there. It looks cumbersome, but that notwithstanding, we were told to identify the reducing agent for 2010 question 22. The key is always to just try and identify things using your definitions of oxidation and reduction reaction, using things like writing the ionic forms of these various equations. If you look at silver here, when you look at triazonitrate 5, NO3 is actually univalent. That's it's an anion. It's having a charge of -1. When you look at silver, silver is actually +1. If you come here, silver is standing alone. Your silver here is 0. So from +1 to 0, that looks like a reduction in oxidation number. A reduction in oxidation number that is actually reduction. So when I look at my silver charge on trade 5, this is looking more like oxidizing agent. I wasn't told to look for oxidizing agents here. You see, silver is +1 here. In the free or combined state here, that is going to be 0. So when I look at this, this is a decrease in oxidation number from +1 to 0. That's reduction. So this is going to be my oxidizing agent. That's not what I'm looking for. Let me proceed to something else. This here is +5, pH3. If I look at it, I have pH3 here, H3 and P here. This looks somewhat as though oxygen has been added to this. Addition of oxygen to a substance is actually oxidation. So if this is oxidation, what will undergo oxidation? That is going to be reducing agent. So my reducing agent here is my phosphine. So looking at the options that I have there, pH3, that is option C. Option C is the correct answer. It is just about you recalling your definitions of oxidation reduction reactions and being flexible with things, not looking at how big or how cumbersome the equation is. Just be precise with your definitions and flow with things, and you definitely will get the right answer. The next question is 2006 question 23. The question says, which of these ions can be used as an oxidizing agent? When you talk about oxidizing agent, you expect oxidizing agent to undergo reduction, opposite but complementary process. So it says, which of these ions can be used as an oxidizing agent? For something to be an oxidizing agent, that's for something to undergo reduction. You're talking of things like gain of electron. You're talking of things like a decrease in oxidation number. So when you say which of them can be used as an oxidizing agent, you simply imply that which of them can undergo reduction, because oxidizing agents will undergo reduction. And what is reduction? If you look at it in terms of electron transfer, reduction is gain of electron. If you look at it in terms of oxidation number concept, reduction is decrease in oxidation number. When you look at this is ion 3 ion. Looking at option A, Fe3 plus can actually become Fe3 plus can actually become Fe2 plus. How? This will be possible if one electron is gained. Here it means that 3 electrons had actually been lost. 3 electron has been lost here. That is why it is ion 3 ion. But if we gain 1 electron, then this becomes Fe2 plus. So this process is actually reduction. This actually, a decrease in oxidation number is reduction. But what will undergo reduction? Oxidizing agent. So I think option A is correct. But when you look at option B, F minus, here what it means is that fluoride ion had gained 1 electron here, and it's this way. For in the case of fluoride ion, you're looking at if it's going to lose the electron so that it becomes F plus E. But of course, that fluorine exists as a molecule. So this is F2, this is 2F, and this will be 2 electrons. So in this case, this is loss of electron. This is oxidation. When you lose electron, it had gained the electron here. Now it has dropped the electron. Now it is 0. It's in the uncombined state. So our loss of electron is oxidation. What will undergo oxidation? Reducing agent. Reducing agent is not what I was told to look for. I was told to identify what can be used as oxidizing agent. When you talk about option C, talking about calcium ion and gold 3 ion, these are metals. Your metals here, they are actually reducing agent. But what we are looking for here, we are looking for oxidizing agents. So the correct option is option A, from iron 3 ion to iron 2 ion. These ones, we cannot have Ca plus, we cannot have Au2 plus. No, they exist this way. They are reducing agent. But in the case of iron 3 ion, it can accept or gain electron and become the, lower ion, the lower version of iron 3 ion, which is going to be Fe2 plus iron 2 ion. So if that happens, that gain of electron is reduction, and what will undergo reduction is your oxidizing agent. So the correct option here is option A. In the case of fluoride ion becoming fluorine gas here, that is going to be as a result of loss of electron. Loss of electron is actually oxidation. What will undergo oxidation reducing agent? So in this case, these are metals. They are actually reducing agents. So the correct answer here is option A. Iron 3 ion is an ion that can be used as an oxidizing agent. Moving on to the next question, that is 2009 question 21. As you can see, it talks about color change for reducing agents. It says the color change observed when testing for reducing agents using acidified potassium heptaoxodichromate C solution is from what color to what color? Actually, acidified potassium heptaoxodichromate 6. Okay, in ionic form, this is going to be Cr2O7, K2 here. That is 2 minus. That's going to end up being chromium 3 ion. You need to understand that K2Cr2O7 is actually orange. That is orange, and it will change to green. So when we talk about K2Cr2O7 to test for reducing agent, the color change of this potassium heptaoxodichromate 6 is going to be from orange to green. If you look at the options there, option B is the correct answer, orange to green. As you see in the next question, 2006 question 9, this year is dealing KMNO4. In the previous question, as 2009 question 21, that was dealing potassium heptaoxodichromate 6. When it is potassium heptaoxodichromate 6, the color change is orange to green. When it is KMNO for potassium tetraoxomanganate 7, it is always from purple to colorless. Okay, from purple to colorless. Here it's going to be MnO4 minus to Mn2 plus. So if you look at that 2006 question 9, as you have on your screen, or you just have this very bogus equation, and they said in the reaction above, the product gives what? A, colorless solution, B, purple precipitate, C, purple solution, D, colorless precipitate. No, we are not talking about a precipitate here. We are talking about having a colorless solution. What we're going to have is a colorless solution when tetraoxomanganate ion becomes manganese 2 ion. And what that actually means is, if we express this in ionic form, the potassium here would actually have this should have a 2. The potassium here would actually have cancelled out the potassium here. The manganese here, when we calculate MnO4 is what we're going to be left with. The sulfate we have here somehow would have taken care of this, but the thing is this: the manganese tetraoxomanganate ion here is going to give us 2Mn2 plus. Whenever you deal KMNO4, it is going to be from a purple solution to a colorless solution. If you look at that particular question, 2006 question 9, the correct option is option A. You're going to have a colorless solution. Option A is the correct answer. But if you deal K2CR207, it's going to be from orange to a green solution. If it's KMNO4, it's going to be from a purple solution to a colorless solution. Taking a look at another question, 1985 question 23, we're told to identify the oxidizing agent in this equation. I know most students, when they see equations like this, they just sort of try to forget about it and just pick any answer at random. Actually, this is not difficult in any way, just like you're thinking. It's just that you're not very confident. You're not trying to recall the definitions of your oxidation reduction reactions. You're not trying to calculate your oxidation number. If you look at this particular equation, not minding how complex it looks like, it's not. So looking at chloride ion here, from -1 to 0, that is an increase in oxidation number. An increase in oxidation number is actually oxidation. From -1 to 0, that is oxidation, because chlorine gas here is in the uncombined state. So from -1 to 0, that is oxidation. What will undergo oxidation is actually reducing agent. I was not told to look for reducing agents. When I look at manganese here is +2. Manganese here is +2. Let me try and look for the oxidation number of manganese here. From MnO4 minus, let my manganese be X. Oxygen is -2. -2 times 4. Everything equals to -1. That is how we calculate oxidation number. So this will be X minus 8 minus 1. So X will be -1 plus 8. So my X here is going to be +7. That means that my manganese is +7. From +7 to +2, that is a decrease in oxidation number. So which means from manganese MnO4 minus to Mn2 plus manganese 2 ion, that is a decrease in oxidation number. You see, from +7 here to +2. So if there is a reduction in oxidation number, and that means reduction, what will undergo reduction? That is going to be oxidizing agent. Oxidizing agent is what will undergo reduction. So when you look at this, the correct answer is option D. Manganese tetraoxomanganate ion is what our answer is. From +7 to +2, that is reduction. What will undergo reduction? Oxidizing agent. The question wants us to identify the oxidizing agent here. So rightfully, D is the correct answer. So it's nothing serious. It's just about looking at oxidation reduction reaction in terms of oxidation number concept, being able to calculate oxidation number and putting things the right way. Moving on, the next question is 2005 question 47. As you can see on your screen, it says, what will happen if an aluminum spoon is used to stir a solution of iron 2 triazonitrate 5? Aluminum spoon dipped into iron 2 triazonitrate 5. Okay, let's look at that in terms of equation. If aluminum spoon is dipped into iron 2 triazonitrate 5, they said iron 2. When you look at it, triazonitrate NO3, it's -1. So when you say iron 2, it means you must have 2 of these, so that you're talking 2 plus. So you need 2 of this for you to have a balanced compound here. So aluminum dipped into iron 2 triazonitrate 5. When you look at aluminum is actually element number 13. So you're looking at 2, 8, and 3. So if aluminum is to actually coexist with triazonitrate 5, you're looking at AlNO3. This will have to happen 3 times, because For aluminum to attain octet configuration, it needs to give out these 3 electrons, and therefore you're going to be needing NO3 minus thrice. So this I know definitely. But then, looking at this, as you're soon going to see when we take electrochemical cells, that's talking about electrochemical cell, or what we call voltaic cell, and when we talk about electrolytic cell, I'm going to show you that in the electrochemical series that aluminum is above iron, so aluminum actually can displace iron. That is to say, aluminum is a stronger reducing agent, or in other words, aluminum is more electropositive. In a nutshell, what this means is that aluminum is capable of displacing iron. So in this case, what my product is going to be is aluminum NO3. I'll be needing 3 of these, just like I said there. So in a bid to balance this, I'll need to put 3 here, and then this I'm going to need 2 here. Okay, 3 times 2 6. So I'm going to need a 2 here. I'm going to need a 2 here. So AlNO3, aluminum triazonitrate 5, with deposit of iron. So when we look at this, aluminum here is 0, but aluminum here is plus 3. Iron here is plus 2. Iron here is in the uncombined state 0. So when you look at this in the question, what we are going to be looking at is from 0 to plus 3. 0 to plus 3, that is an increase in oxidation number. An increase in oxidation number, that is oxidation. So in other words, we say aluminum is reduced. So this here is going to be my reducing agent. Now talking about iron triazonitrate 5, iron 2 triazonitrate 5 here, iron from plus 2 to 0 here, this is going to be a decrease in oxidation number, that is reduction. What will undergo reduction? That is going to be my oxidizing agent. So looking at the option, as you can see on your screen, they said the spoon will be reduced while the iron 2 will be oxidized. No, the spoon is not going to be reduced. You see, this is the aluminum spoon. This here is my spoon. The spoon, what it is undergoing is oxidation. So option A is definitely wrong. The spoon will be oxidized. Iron 2 ions will be reduced to metal. The spoon is going to be oxidized. Iron 2 ion will be reduced to the metal. Yeah, this is in the uncombined. Say iron 2 ion will be reduced. When you look at that option B, the spoon will be oxidized while the iron 2 ions will be reduced to the metal. Option B is correct. You look at option C, it says the spoon will be reduced. No, the spoon cannot be reduced. The spoon will be oxidized. The spoon will increase in size. No, that is not the answer. So the correct option here is B. The spoon will be oxidized while the iron 2 ions will be reduced to the metal. Option B is the correct answer. Nothing too spectacular about that question. Let's take this final question on how to identify reducing and oxidizing agent. In this question, 1998 question 32, as you can see on your screen, we were given about 3 sets of equations, and we were told, as you can see in that question, the reactions represented by the equations above demonstrate what? What are this equation set of equations 1, 2, 3 are demonstrating? Okay, let's look at it very closely. This here, I can look at this in terms of hydrogen. When you look at this, NH3 becomes N2. So when you look at this, there has been a loss of hydrogen here. Loss of hydrogen from a substance or removal of hydrogen is actually oxidation. What will undergo oxidation? This is a reducing agent. This is a reducing agent. That's what I can say. So we are looking at the reducing ability of ammonia here. If I come here, the same thing had happened. Ammonia had become nitrogen, so I'll be looking at the reducing ability of ammonia as well. When I come to the equation 3, ammonia had actually become nitrogen gas. Here again, I am looking at the reducing ability of ammonia, so to speak. So when I look at all this, it is not about the basic properties, because if you say you're looking at the basic property, you're seeing ammonia as a base. Yes, it is true that ammonia is the only alkaline gas, but the other reactant is not an acid, so you cannot be talking about the basic properties of ammonia. So that renders option A wrong. If you think you're looking at acidic properties of ammonia, first of all, ammonia is not even an acidic gas. And if that were to be true, if this is an acid, these are not bases, these are not alkalis, these are not basic compounds. So that renders this out. It is between reducing and oxidizing ability. And when you look at the 3 equation, ammonia becoming nitrogen, loss of hydrogen from a substance is oxidation. What will undergo oxidation? Reducing agent. So you're looking at the reducing ability of ammonia, and there option C is the correct answer. And with that, we've come to the end of everything that has to do with oxidation and reduction reactions. Do not forget, hit the subscribe button, share with your peers, and if you, of course, if you have any questions or other questions, or you're trying to attempt as far as redox is concerned, you've been having issues with them, don't hesitate to put them in the comment section, or check us out on our website 300plusacademy.com, and of course hit us up on WhatsApp and drop your questions. We'll be glad to attend to your every question. From myself and the entire team, it's bye for now.